Well, this is City Swivel, and City Swivel is a community-based promotion platform. And with it, what we're doing is allowing our retail community, the small business community, to actively promote themselves, each other, and the nonprofit profit sector, as well as the community storekeepers. And we do this through an app, a mobile app on both iPhone and Android, and the back end, which the business runs, in which they create tours, interactive tours throughout the community based on historical backgrounds, cultural backgrounds, arts, and things that will appeal to the communities and other tourists.
Okay, what's the name of the app?
The app is called City Swivel, and you can find that on the App Store, either iPhone or Android.
Yeah, I'm Peter Romine from Navajo Tech University, and I'm here with Chris Storr and Tom Bebo and Hanson Tapaha. And Chris is a welding instructor there, Tom's construction, and Hanson is actually one of our recent graduates from our engineering program. And so here, behind us here is Iron Man that was built by high school students up in Many Farms, Arizona. And so Chris is actually teaching the students there how to weld, and they're going to be building a solar system using that skill within the next 2 weeks. We're halfway through the program. Tom is teaching students carpentry and construction down at the main campus, and he's got a slideshow going here. And so here are you see construction students doing stuff, and we got welding students, and they're also learning AutoCAD Inventor. So this is a piece of the solar system is printed here, so the students, the high school students are getting dual credit for this. They're getting college credit and high school credit. And so they're very excited. You see a few of them around here. I told them, hey, why don't you go check out the plaza? And so a lot of them are out there, but a lot of them, I guess it's their first time probably in Santa Fe, and they didn't know they were makers. I've been telling them they're makers, but they now know that they are. And so they're really excited. We've got a lot of students that have just, during this 2 weeks, have gone from, oh, I don't think I'm going into college, to I'm going to college. and luckily some of them, 3 of them are coming to Navajo Tech, and I'm working on more. And so, but it's just a lot of the students are like, college is not for me, right? But they didn't know that there are other kinds of college, and there's other kinds of programs. And so like I said, so some of these students will go to a tech school, or like I said, Navajo Tech, they can come and get a certificate in welding, a certificate in construction. They can continue on and get an associate's degree, a bachelor's degree. Hanson actually went that route. He started out as an electrician, and then a couple years ago he came and enrolled in electrical engineering, and so now he's an electrical engineer working for the federal government. And like I said, he's an example of the success of making at the university. And so he was actually, you could say, our first maker that really did it from the understanding of what the idea was. We went to the 2015 DC Maker Fair, was our first introduction to making, and so we've been just really growing in that, and since then. So
Awesome.
yeah, we're really.
Hi, I'm John with Forest Scientific, and we supply equipment that's used in maker spaces and fab labs, really elementary through university level all over the world, as well as in actual manufacturing and manufacturing of products. And this machine is a CNC router, and it's used primarily for woods, plastics, although they're also used for aluminum and other types of materials too. What we've done is in CAD/CAM software, we've drawn up a coaster. And so what we're gonna do right now is cut out a pocket within this wood to be a coaster, to set like a soda can in, so that when the water comes off of it, the condensation, it doesn't go all over your desk or a coffee mug. So that way the little bits that spill into it doesn't spill out all over your desk. And so it's cutting out the wood right now. And routers come in all sizes. This is a small one for demo purposes. A lot of them are 4x4 foot, 4x8 foot, 5x10 foot. Could be very large. And I forgot to turn the dust collector on, so we have a little bit of spillage, but that's okay. It'll vacuum up just fine. Now this could be held with vacuum. I'm using clamps today just because I didn't know how much electricity we'd have to run a vacuum pump. So here's our simple finished piece. And so this is the pocket that you'd set the cup or the pop can, soda can, whatever on. Now that this is done, we can customize it. And how about I add your name, Gene? Okay. So I'm going to just go into the software, and I can simply delete what was in there. G-E-A-N, let's see. G-I-N-D-R-E-A-U. Make sure I didn't misspell it. And I'm just going to center it down a little better. That looks better. And then I just hit print. And the beauty of this machine, it really makes it simple because I can say wood, plastic, whatever material it is, give it the thickness so that it knows exactly what the thickness is, so it can adjust the laser beam for that material and for that thickness. Hit OK, and hit print. So it's not much harder to work than any other printer. And then I can go into my software, I can see it, I can further preview, make sure that everything is correct. And once I'm happy with it, just close the lid and hit start, and then it'll start moving. The laser beam will actually be burning that image into the wood. It's easy enough that even like a 5-year-old kid, literally when my youngest son was 5, he could do these demos for me.
These are all sorts of things that you've done.
Right, these are various materials. The laser is really versatile. You know, here we have rubber, leather, wood, glass. Leather is over here, wood's here. Anodized aluminum, marble, plastics. You can not only cut things out, but you can engrave into them. Materials like denim and so forth. You could just engrave part of the surface off, change it, or you can cut it pieces out and put them together. You can even do like a 3D type thing with it. The router is really good at 3D type work. You could draw a horse and it looks like a horse in 3D. So it just gives you so many ways of doing it. Marble here.
So are you marketing this?
Yes, we manufacture the machines that are used in fab labs, maker spaces, schools, manufacturing all over the world.
How much does something like this cost?
They range in price. Like a small CNC router could be as little as $5,000 on up to $200,000. Same thing with laser. You could be around probably as little as $8,000 on up to whatever. And there we are. Trying to.
So at Symphony, what we are is a STEM clearinghouse. So we currently have over 30,000 different resources from pre-K to college. Think of robotics, drones, 3D printers. But the overall goal of Symphony is to make STEM accessible. And so with the 30,000 products, all of them have curriculum, they're hands-on, just ways to get the kids pumped up and learning math and science and STEM. At Symphony, we also help schools out and libraries out and makerspace programs and getting funding. We do a STEM grants program. We have over 1,000 free STEM activities available on our website. And we also offer professional development and have a variety of different trainers that come out and train the teachers and the educators on how to utilize the material effectively. But we're continuing to expand and try to find ways to make makerspaces more engaging and fun and easy to implement. So, all right.
So we are the LemelsonMIT Program. We are actually at MIT in Cambridge, Massachusetts, but we run as an independent center there, and our mission is around invention. And so we do that in a few different ways. We have prize programs for a mid-career inventor and for collegiate inventors. And then we have invention education programs, which is mostly what we're focusing on here today. And those programs are to introduce the concept of invention to kids. So for middle school, we have prescribed invention activities, 8 different curricula with an activity kit that goes with it. It's not an actual invention, but it walks kids through what it would be like to invent something and the steps that you have to take. And then we have an Invent Team program, and that is 15 grants that we give out every year to high schools across the country. They identify a problem in their community, and over the school year, they work with their teacher to invent the solution. And then they come to the MIT campus in June, so the week after next we have this. We have 15 teams coming, plus our 11 student prize winners, the collegiate prize winners, and they're all bringing their inventions to show off to the community there. So yeah, it's very exciting.
All right, we're making artist books. These are tunnel books made from 5 panels representing the golden ratio. We laser cut the 5 panels, and we're using a technique, a printmaking technique called pochoir to add color to the panels. So you are using basically just a stamp pad and a flat bristled brush, and then stippling really hard and then onto the paper. And it allows you to get really interesting gradients with this technique. And then the panels are hinged together with these accordion hinges on either side. So this is an uncolored but completed book.